In this video, we're looking at section 3.3, function notation. Looking at our learning targets for this video, at the end of the video, you will be able to use function notation to evaluate and interpret functions, as well as use function notation to solve and graph functions. All right, so we are evaluating a function for example 1. We can see our function here. This is a linear equation. And the way we say this is f with x in the parenthesis. This is f of x. So f of x is equal to 2x minus 7. So we want to know what's f of x, or what is the output when x equals 4. So our equation, f of x is equal to 2x minus 7. In our first situation here, we have x equals 4, so we're going to substitute x equals 4. So we're going to look at f of 4. The way we say this is f of 4 is equal to, so wherever there was an x, we're now going to substitute in the number 4. So we have 2 times 4 minus 7. And when we simplify this, 2 times 4 is 8, and we're subtracting 7, and 8 minus 7 is 1. So f of 4 is equal to 1. Let's look at when x is negative 4. So we're looking at f of negative 4. So we plug in or substitute negative 4 where our x's are in the equation. And we continue to simplify. So we have 2 times negative 4, which gives us a negative 8 minus 7. Negative 8 minus 7, negative 15. Okay, in example 2, we're interpreting function notation. So look at, we have f of t. Let f of t be the outside temperature in degrees Fahrenheit t hours after 10 a.m. Explain the meaning of each statement. So f of 0 equals 75. So since this is in terms of t, and t represents the number of hours after 10 a.m., in this equation, t is equal to 0. So it's saying at time 0, so 0 hours after 10 a.m. So that really means at 10 o'clock or 10 a.m., the temperature is 75 degrees. So we could say at 10 a.m., the temperature is 75 degrees Fahrenheit. The next one, f of 3 is equal to n. So we can see that the t is equal to 3. So 3 hours after 10 a.m. So 3 hours after 10 a.m. is 1 o'clock p.m. So at 1 o'clock p.m., the temperature is n degrees. So at 1 o'clock p.m., the temperature is n degrees Fahrenheit. And lastly, this is saying f of 1 is greater than f of 8. So f of 1 is when the t is equal to 1, so 1 hour after 10 a.m. So that would be 11 a.m. So that would be at 11 a.m. The temperature is greater than at, when t is 8, we're looking at 8 hours after 10 a.m. So that's 6 o'clock p.m. And that's going to be the temperature in degrees Fahrenheit. So the temperature in degrees Fahrenheit at 11 a.m. is greater than the temperature in degrees Fahrenheit at 6 o'clock p.m. Okay, in example 3, we're solving for the independent variable. Remember, the independent variable is really going to be our x value, or this is our input. Another way to say it is our input. So we have 4g of x is equal to 1/3 x minus 2. So I'm just going to rewrite that. G of x is equal to 1/3 times x minus 2. And we want to find the value for x that's going to give us the function g of x equal to -4. So there's some x value we can plug in here, or substitute in, that will make this whole g of x become -4. So really we're solving for our independent variable or our input. So we have -4 equals 1/3 x minus 2. And then we're going to solve the equation. So we add 2 on both sides, and we get -2 is equal to 1/3 x. To get rid of the 1/3, or the 3 in the denominator, we're going to multiply both sides by 3. So the 3 and 3 cancel, and we're left with 1x on the right and -6 on the left. So when x is -6, the function is going to evaluate to -4. And we can check this. We can plug in g of -6 and see what happens. So we use our original function 1/3, but instead of using x, we're going to plug in a -6. And we're subtracting 2. Well, we know g of -6 is evaluating to -4. And this is our check here, so let's put a question mark. We want to see if the left equals the right. -6 divided by 3 is a -2, so we get -2 minus 2. And we're checking to see if -4 is equal to -2 minus 2, which is -4. So sure enough, they're equal, so it checks out. Okay, we're graphing f of x equals 3 minus x. So we have this function notation for our linear function, and we're going to graph it. So we can expect that we should see a line when we graph it, but we need to identify input and output values. So we're going to make an input-output table, or what I like to call a t-table. And it's a t-table because it looks like a t. So we have our inputs, we have our outputs. So since we're graphing here in our coordinate plane, let's enter in some values that are negative for our x, as well as some values that are positive. Now I'm entering in 5 input values, so I'm going to get 5 output values. So when I substitute x equals -2, I have 3 minus x is a -2, so 3 plus 2 minus a negative becomes plus. We end up with 5. When we use 3 minus -1, we have 3 plus 1, which is 4. 3 minus 0, we get 3. 3 minus 1 is 2, and 3 minus 2 equals 1. So we're ready to plot our points. So this point is -2, 5. This ordered pair is -1, 4, etc. And so our x values and y values. So we're here at -2 and we're going up 5 units. We're at -1 and we're going up 4 units. We're at 0, 3, 1, 2, and 2, 1. So this is our linear function.